Hi everybody, this is Arif. Today we will solve a linear collision problem which I think AP Physics students and first year college students are going to like a lot. So please read the question first and then we will get started. Okay, if you are ready, let's get started. In this problem, we have a cart here, which is 1 kilogram moving in the positive x direction. So I choose positive x to the right. So it has a speed of 10 meters per second. On the other side, we have a launcher which launches sticky balls, each of which is 0.01 kilogram or 10 grams, okay? And the launch speed here is equal to 100 meters per second. And this is horizontal, right? This is good. So these sticky balls hit this cart and they stick, okay? So it is a totally inelastic collision, right? Each of these collisions is totally inelastic, okay? So in this problem, we are trying to find the distance this 1 kilogram cart can move in the positive x direction, okay, until it stops. That would be the maximum distance that this cart can move in the positive x direction. So of course we have some assumptions in the problem that they are given. So they say that there is no friction. This is good. So in the collisions, during the collision, there are no any external forces affecting the system in the x direction, like in the horizontal direction. And we also neglect g, gravity, but it is not of a big deal here because even if these sticky balls follow a trajectory of a projectile, when they hit this mass, 1 kilogram cart, the y component of their momentum will be taken care of by the normal force here. So there will be an external force acting in the y direction, in the vertical direction. That external force actually prevents the system from moving up or down, right? So we don't really worry about the y motion. We know nothing is going to move in the y direction. So what's going to stop this cart is the x components of the linear momentum of these sticky balls. So one other information which is given in the problem is that the frequency of this machine is set to 0.5 Hertz. In every 2 seconds, we have one ball, sticky ball sent by this machine. So how do I see that? T is equal to 1 over F, right? So this gives me 2 seconds. So the time interval between these two sticky balls is 2 seconds. Let's find the distance between the horizontal distance between two successive sticky balls. So there's one here, the other one is up here following the first one, and they are both moving at the same speed horizontally, 100 meters per second. So if the time difference between them is 2 seconds, right? So this distance is simply equal to 100 meters per second times 2 seconds is equal to 200 meters. Okay, so let's first find the momentum, the linear momentum of this cart initially. So P cart is going to be equal to 1 kilogram times 10 meters per second, which is equal to 10 kilograms meters per second. I'll be looking at the collisions, so it would be a good idea to find the linear momentum of one of these sticky balls. Let's call it P sub B. So its mass is 0.01 kilogram. Well, the x component of its velocity is actually minus 100 meters per second. This actually gives me minus 1 kilogram meter per second. So the linear momentum, or the x component of the linear momentum of each of these sticky balls is equal to minus 1 kilogram meters per second. So let's first look at the first collision. So what happens during the first collision? Well, we have the box, the cart, moving to the right, and we have the sticky ball, the first one, coming like that. So what is the initial linear momentum of this system? This cart and one sticky ball. So let's call it P1 initial. So this would be equal to 10 minus 1, right? So it's going to be 9 kilogram meters per second. So after they collide, what happens? So after they collide, they move together to the right. So let's call this the velocity to be V1 final. So it's the final velocity after the first collision, okay? So V1 final will be equal to the momentum of this system, which will be equal to 9, right? Because we will conserve the linear momentum in this collision. So it's going to be 9 kilogram meters per second divided by the total mass of the system, right? So what is that? 1 kilogram plus 0.01 kilogram. So it's going to be 1.01 kilogram. So using this, you can solve for V1 final. So similarly, let's look at the second collision. Let's look at the second collision and see what's happening here. So we have the cart and one sticky ball already attached, right? So they go with V1 final with this speed to the right, and there is the second ball coming, right? With the speed 100 meters per second. Okay, so if I'm just looking at the second collision, so what is the linear momentum of this system now? This cart plus this sticky ball plus this sticky ball. So let's call it P2 initial. So this is the linear momentum of this system before the second collision, right? So P2 initial is simply equal to 9. So this is 9, right? 9 kilogram meters per second. And this is minus 1. You already found it. So P2 initial is simply 8 kilogram meters per second. So after the collision, what we have is, we have two sticky balls and one cart, right? So they are moving to the right with V2 final. So how can we find V2 final? So V2 final will be equal to the linear momentum after the collision, which will be the same as this 8, right? So 8 kilogram meters per second divided by the total mass of this system now. So it's going to be 1 kilogram plus 2 of these sticky balls. So 1.02 kilograms. And this is how I can find V2 final. This is good. So I will keep doing this for all the collisions until I will get zero momentum, right? So one question here. How many balls or how many collisions are needed to stop this cart? Okay. Well, 10, right? 10 sticky balls. So the linear momentum of 10 sticky balls will add up to minus 10. And this already has 10. So when I take that system, like one cart and 10 sticky balls, well, the linear momentum would be 0. So the system is going to stop. Okay? So now what I need to do is I can plot V versus time graph. Okay? So initially, I'll have some speed V0. So let's call it V0. 10 meters per second. After the first collision, so since the collisions are instantaneous, so I'm going to start my time after the first collision, right? So this is going to be V1 final. So it's going to be just like that, right? So this is delta T1. So what does delta T1 mean physically? It's actually the time interval between the first and the second collision, right? So when we have V2 final here, so after the first collision, we have V1 final. After the second collision, we will have V2 final. So this will be delta T2, right? So how can we find delta T1? The time between these two collisions, right? Let's write it down, delta T1. Well, I already know the distance between two sticky balls. So after the first collision, the distance between this system and the second sticky ball is actually equal to 200 meters, right? Right. So I need to divide it by V1 final plus 100 meters per second, right? Why? Well, let's do a simple example here. So let's suppose I have a box moving to the right with 10 meters per second. I have another box moving to the left with 10 meters per second. And let's suppose the distance between them is 100 meters. So the question is when these two boxes meet, or when do they collide, right? At what time do they collide? Well, in 1 second, this box moves 10 meters to the right. This box moves 10 meters to the left. Well, so after the first second, the distance between them becomes 80 meters. So in each second, the distance is reduced by 20 meters, right? So then they meet after 5 seconds, right? So how did we do the calculation here? Say that 100 meters divided by 10 plus 10. So 10 plus 10 here, meters per second, is the relative speed, right? So let's suppose you're on this box, okay, and looking at the second box coming towards you. So what would you see the speed of the second box? You would see the speed to be 20 meters per second, right? This is the relative speed. And the distance between you and the other car is 100 meters. So 100 divided by 20 gives you the time, which is 5 seconds here. So same idea. Similarly here, what we say is the speed of this system is V1F and the speed of this one is 100 meters per second. And I know the distance is 200 meters, so 200 divided by V1F plus 100 gives me this delta T, the time between the first and the second collision. Well, you can do the exact same thing for delta T too. So this is the time between the second and the third collision. So after the third collision, the speed would be V3F, right? So the delta T3. So delta T2 would be equal to, similarly, 200 meters divided by V2F plus 100, right? This is in meters per second, of course. And this is how you can calculate delta T1, delta T2. So as you see here, V2F is going to be less than V1F, right? So then delta T2 is going to be bigger than delta T1. So in other words, the time between successive collisions is increasing as time goes by, right? In the end, what we need to find is, we want to find the distance traveled, right? So we just need to calculate this area, okay, under this V versus T graph. So there will be other, of course, time intervals, right? So you need to keep doing this until you get zero velocity. So you'll have 10 collisions, right? We already solved that. Well, since there are like 10 collisions, I mean, I may want to do that, but if I change the numbers here, for example, so if I make this mass to be 0.001 kilogram, okay, instead of having 10 gram sticky balls, if I use 1 gram sticky balls, so it would take 100 collisions, right, to stop this cart. So would you do this thing 100 times? So we need to come up with something a little bit smart to solve this problem. So let's take a step back and think about it. Would there be another way to approach this problem? Okay, let's think in terms of system of particles. Okay, so I already answered that. There are 10 balls, sticky balls needed to stop this cart. 10 sticky balls, and I have 1 cart. Oh, this is good. So how about if I take the cart and 10 sticky balls as my system? So I want to look at the big picture, okay? Instead of dealing with each collision separately, let's look at the big picture, okay? Let's draw what's happening here. let's draw what's happening here. I have a cart. The first sticky ball hits. The second one is coming here. There is the third one, fourth one, fifth, sixth, 7, 8, 9, and 10. Do I know their location? So I'll set this to be x is equal to 0. So the second one is going to be at 200 meters, right? And this would be at 400 meters. So it will keep going on like this. 400, 600, 800, 1000, 1200, 14, 16, and this is going to be at 1800 meters. This is good. And they are all moving to the left with the speed of 100 meters per second, right? I already know that. And this box is moving to the right with the speed of 10 meters per second. First question, what is the linear momentum of this whole system? Well, I already know that this is 10 plus minus 1 times 10. So the linear momentum of this system is actually, initially when time t is equal to 0, see, is simply equal to 0. Interesting. And we are looking at just collisions here, linear collisions, right? And there are no any external forces, so this is actually the x component, right? P initial x, let's say P initial x. So there are no any external forces in the x direction during the collisions. So this P initial x is going to be a conserved quantity. So we have been conserving the linear momentum, right? So the linear momentum of this system would be always equal to 0 in the x direction. So this gives you something really, really interesting, right? So if you remember the definition of center of mass, okay, x, p of x divided by, so the velocity of the center of mass of this system, the x component of that is equal to the linear x component of the total linear momentum of the system divided by the total mass, right? So if I call this m and this one little m, this would be m plus 10 little m, right? But this is going to be 0 because the linear momentum is always 0. Okay, what does this tell you? The center of mass on the x-axis is actually stationary. It's not moving, right? So x center of mass is not changing. Okay? So now, how can I find the x center of mass at t is equal to 0 then? Let's find what is x center of mass when t is equal to 0. So this is going to be m times 0 plus little m times 0 plus little m times 200 meters, right? Plus dot, 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 dot. The last one would be m times 1800, right? Divided by the total mass plus the mass of the cart plus 10 times the little m. Okay? So here this term is 0, this term is 0. So x center of mass when time t is equal to 0 is, so I can put m and 200 parentheses. So it's going to be 1 plus 2 plus dot 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 all the way to 9, right? Divided by m plus 10n. Okay, so x center of mass when time t is equal to 0 is simply equal to, so little m is 0.01 times 200 gives me 2, right? So this is 2 times the numbers, the sum of numbers from 1 to 9. It's equal to 9 times 10 divided by 2, right? It's going to be 45 divided by m is 1, 10 times little m is 0.1, so it's going to be 1.1, and the units is going to be meters. So this is nothing but, if you calculate it, 90 divided by 1.1, it's close to 82 meters. But this is the location of the center of mass when t is equal to 0, right? So let's look at what happens when all the sticky balls are on top of this cart. Okay? Let's look at that. Suppose this my x is equal to 0. So the cart is going to be here, right? And there will be 10 of these sticky balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Let's call this as D, right? So at this point, they're all at rest. Okay? So in other words, what is this D? So all the mass is located at D. Well, this is the center of mass of the system, right? So then this D is simply equal to 82 meters, because this is the center of mass of this system. So this box travels 82 meters before it stops. And this is the maximum distance that this box can move in the positive x direction. And this is the answer. So as you see, the definitions in physics are really, really important. The way we choose our system, okay, in a problem is highly crucial. Okay? The definitions in physics, like the center of mass, right? It is not something made up, okay? So this is defined for some purpose. This actually helps us analyze the systems, okay? And it actually helps us simplify the problems. I hope you enjoyed it. If you have any questions, please ask them in the comments. And I look forward to seeing you in the next videos. Take care. Bye.